Welcome back to Dilemmas Concepts. Today we're looking at coordinate geometry. So we're looking on our graph here where we have a line AB. We got coordinates for the point AB. So we could see that this line would have passed through those points. The first question is asking us to find the gradient of AB. What we would love to do is that we'll take our points, we will label them, and then from there we'll calculate. So let us write down the point A. The point A is -1, 9, and the point B is 3, 1. We want to label these points very early, so I'm going to label them. So we have x1, y1, and then where we have x2, we have y2. Now, the gradient can be calculated by using this formula. So our gradient can be calculated all the time by using this. Y2 minus Y1 over X2 minus X1. Remember, the gradient is really the change in our Y over change in X, or what we'll call a rise over run. Let us substitute and see the numbers that we're getting out. So if we substitute, Y2 would have been 1, and we're going to subtract Y1, which is 9. X2 is 3. We're going to subtract X1, which is a -1. We want to pay attention to the details. This subtraction here is a part of the formula, but this is a -1 that was coming. So we have to make sure that we don't ignore what's going on. So something is going to happen as it relates to those. So let us finalize this. On top, we're going to have 1 minus 9. That's going to give us -8. And then whenever two negatives clash, it becomes a plus. So this is actually +4 that we're having. 3 plus 1, 4. -8 divided by 4 is -2. So we're looking at a gradient of -2 for AB. So let us see what the other questions are. So our second question says, determine the equation of the line AB. Now, if we're going to determine the equation of a line, it depends on the format that we want to write it in. So there are multiple formats. I'm going to choose the slope-intercept form. So I'm going to write the equation in this format. So I'm going to write it in y equal to mx plus c, where m is my gradient and c is my y-intercept. So basically what I need to do is I only need to know what m is, which is my gradient, and I need to know c, which is the y-intercept. But I'm looking at my c value here for this. So currently, I do not need to work this out because this is 7 right there. So let us write down what we have. So I do have my m value, which is the gradient. We found that to be -2. And my c value is where the line AB would have crossed the y-axis, and it did cross it at +7. So my c value is a 7, which means I could just simply write the equation of the line AB. It's going to be y equal to -2x plus 7. So this is the equation for this line AB. All right, now let us go to the third question. So for this third question, what we are up for is we want to write the equation of a line P. So there is this line P that is perpendicular to the line AB and passes through the origin. And when we speak of the origin, the coordinate for the origin is 0, 0. That's where the x and the y axis meet. So it's going to pass through right here. What it is that they're actually asking for, I'm just going to drop a quick line so you could see it. They're suggesting that there is this line that passes through the origin, and when it touches AB, it is at 90 degrees to it. So basically, when it touches AB, it crosses at 90 degrees. So they want the equation of this line that they call P. Okay, so when it touches AB, it crosses it at 90 degrees. And the thing is, when lines are perpendicular, then one gradient is the negative reciprocal of the other gradient. And another thing that we do know, let us say we call the first gradient M1, and that's the gradient for AB. If you should find the other gradient, let me call it M2 for the second gradient. And if you multiply these, you'll get -1. So the product of two perpendicular lines gradient always give it -1. And it's because one is the negative reciprocal of the other one. For example, the gradient for AB is -2. And -2 can be written as -2/1. Now, the gradient for any line perpendicular to AB will be the negative reciprocal. So if you should flip this, you're going to get a half. And since this was negative, it means that this one must be positive now. So the half is positive. I'm suggesting if you should multiply these, you would realize you get -1. This is the gradient for the new line that is perpendicular, this line P. So we do have a gradient for line P, okay? So the gradient for line P is +1/2. And guess what? They did say that it passes through the origin. And if it passes through the origin, it means the y-intercept is actually 0 because that's 0, 0. So this is the y-axis and it did touches it at 0, which means that we could easily just work this. We don't need to work this out. We could just write this up properly because y is now equal to my gradient, which is 1/2. X is always here. And +0, we don't really need to write +0. We could just leave it as y is equal to 1/2 x. And this is the equation of the line P, right? That is perpendicular to AB and passes through the origin. Let's take a look at our last question. For our last question here at number 4, what we want to do is we want to write the equation of a line T, and this line T is parallel to AB and it passes through the point 2, 0. So what it is that they are looking for? Well, they're looking for a line that looks something like this, okay? So this line right here would have been parallel. So this is the line that we're referring to, right? So it's parallel to, let me put it in another color, maybe in the red. So it is parallel to AB and it passes through 2, 0 there. So what it is that we need, again, we still need the gradient of this line and we need the y-intercept. We don't know the y-intercept. We're going to work it out. Now, here's the deal. Parallel lines share the same gradient. So let me refer to these. So the gradient of AB, let me call that M1, the gradient was -2. Because parallel line would have the same gradient, then I'm going to call this line T, I'm going to call the gradient 3, M3. The gradient will be the same as -2 because parallel lines do share the same gradient. So the only thing we need to find out is that we need to find the C value where it crosses the y-axis. So what I'm going to do is to work it out because I'm not going to trust this because I just dropped the line there, okay? So what we could do is to use this form. Y is equal to mx plus c. And then I'm going to take this gradient because the gradient for M3 is -2. And I'm going to take the point that it passes through, right? Which is 2, 0. Remember, this is an x value. That's a y value. I'm going to substitute these three values right here and find c. Let us work this out. So y is 0. This is equal to m, which is -2. And then x is +2 plus a c. All right. So as you could see, 0 is equal to -4 plus a c. And as you could see here, c is going to be 4. So we're certain that it is 4 right there. All right. So the diagram I have seems as if it has some form of accuracy to what I just drew. It was a rough drawing, but it's good. So if we add 4 to both sides, then you could see 4 is equal to C. So it did crosses it at 4 for real. So here's the thing now. Since I know that my C value is 4 and I have my gradient, then equation is negative 2x plus 4. And that's it. Thank you for watching Dilemmas Concepts. I'll see you next time where we will be looking at more videos.